Okay, what you will study? Introduction. First chapter, introduction. In the introduction, what you will say? In the introduction chapter, you will have to see the sheet, which I have PDF slide actually, a slide, a PPT slide. Here, the definition of the control system, the types of control system, open loop and closed loop control system. Okay, the types, definition, types, as well as you'll see the some example like the boiler and boiler example and the autopilot example. Okay, and the block diagram. There is a block diagram, the design process. Okay, you'll have to check this on. Okay, and in the control system example, you should have get some idea. Should have some idea based on what kind of examples are there. Which one is the example of open loop system, and which one is the example of closed loop system. Okay, you have to ensure that that is open loop, that is closed loop. Okay, so take this point, and in the frequency domain, you have some maths. I've shown you like the basic math, electrical network transfer functions. Okay, you see some maths as well as some translational mechanical system, rotational mechanical system, gear system, electromechanical system, transfer functions. Okay, these. Okay, just look at the maths. There are no theory in the chapter 2, only maths. In the chapter 3, you can check here also. Here are some also some maths. Okay, so I will give you something like that, like chapter 1, one question. Okay, chapter 2, one question. Chapter 3, one question. So total 3 question. Answer you need to. Okay. So it would be your 10 marks. Okay. It would be a 10 marks. So here you can do one thing. You can skip any one chapter. Okay. If you think that is difficult for you, then you can skip any one chapter and focus on other 2. Okay. So 10 marks comes from here, and we have another 10, which is the viva. Okay, which is the viva. Viva, another 10. But in the viva, I will not distinguish. I can ask you from anywhere. Okay, I can ask you from anywhere in the viva. So keep in mind that in the viva, you have to take care of this. Okay. So that is your kind of suggestion. How would you take preparations to complete the things? Okay. So any questions from you guys?
I have a question.
Yeah, please.
Yes, sir. In the 5 sir questions, maximum how much question you ask us?
Oh, Viva, it depends. Maybe 2, maybe 3. Okay, it depends on the situation. Okay, but I can do another thing. Let's say I can ask you 5 questions and I can give you marks based on that. Two, each question two. It could be another thing. If I ask you 5 questions, each question will carry 2 marks. Or if I ask you 3 questions, each question will carry 3.5 marks. Okay, 3.5 or 3 is average, on an average. Okay, that it depends. It depends on the situation. If I see that I do not have much time, and I have other work, or you have some other problems, and then we can reduce. Now tell me, what is your date, exam date?
Yes, sir.
Grossly?
Yes, yes, sir.
Yes, sir.
Date. What is the date?
Sir, 8th of this month, 8th of October.
Don't you have the routine yet?
Yes, sir, we have. It is 8th, sir.
Yeah, just check. So any more question?
Sir, chapter 3, sir.
Chapter 3,
Yes, sir. Example 3.5, sir.
example 3.5. Okay, let me go to here, there. This one.
Yes, sir.
Okay. Now look here. This block. Okay. You have to look at this block. This one. This block. We can split this block. We can split this block like this. Okay. Just take this one. Take this upper part to the another one. Upper part to the another one. X square plus 7s plus 2. And the other part 1 by this part to here. Okay, you can split this. Like say if I let's say another example like say 5 divided by x plus 2. So you can write this like this form. 1 over x plus 2 here the 5. Similar thing happened here. Okay, this is means what? This is means you are multiplying this. So if you multiply this into 5, then it would be 5 by x plus 2. Similar thing happens here. So if we multiply this, then this thing will arrive. Right? That is why they do this. Okay. So see here another thing. RS, and this is the input, and this is output. But here in the middle, since we split it into two subsystem, so we'll add another thing. That is the another output. That is the internal output. Okay, internal output. So this is RS, this is X1S, this is CS. Okay. Okay. Now, just you do not memorize this thing. You can skip this one. Now see. At first, what you have to do. At first, you have to solve this one. You have to solve this block. Here the input of this block is RS and output is X1S. So you have to solve this block. So how to solve it? To solve this, you have to apply the state space representation to solve this one. For solving it, you can write like that and say X1 is by RS is equal to what? Is equal to 1 over SQ plus 9s square plus 6s plus 24. Okay. So what you will do, just cross multiplication. If you do the cross multiplication, then RS equal to 9s square plus 26s plus 24 X1s. Okay. Now take the inverse Laplace transform. Taking the inverse Laplace transform, you'd see if we take the inverse Laplace transform, then what would happen? X1 triple dot plus 9 X1 double dot plus 26 X1 single dot plus 24 X1 is equal to R. Okay, RT or R. Okay. Now what would happen? Now, if you take the internal variable as like x1, x2, or x3, let's say x1 is equal to x1. Then x2, x1, one derivative, x3, x1, double derivative. Okay. Now, if you differentiate it, then what would happen? X1 dot means x1 dot, which is equal to x2, and x2 dot, which is equal to x1 double dot, is equal to x3, and x3 dot means the x1 triple dot, and x1 triple dot means here. So x1 triple dot means what? From this one, x1 triple dot is equal to minus 24x1, minus 24x1, minus 26x1 dot, minus 9x1 double dot, plus r. But x1 triple dot is equal to x3 dot, or we can write the x3 dot, and see minus 24x1, it would be as it is. x1 dot means x2, minus 26 x
Sir, another 24 you left.
24, yeah, 24, sorry, 24 x1, yes, sorry, 24 x1, yeah, minus 24, it would be minus, okay, minus 24 x1, or 24 x1 here, I write here.
There is a 224, sir.
No, this one, if I change the minus, it will be minus, okay, it will be minus, it is okay. Plus r, 26x2 minus 9x double dot, 9x double dot means what? x3, 9x3 plus r. Okay, so what are the coefficient? Minus 24, minus 26, minus 9. So if I make it matrix form, so x1 dot, x2 dot, x3 dot, okay, and here coefficient would be, look at the coefficient, first one only x2, that means x1, so if I write this one 0 1 0 0 0 1 for the x3, minus 24, minus 26, minus 9, minus 9, and here, and plus for the r1, first 3 0 0, sorry, it would be 0, the last it is 1, and here the r. See this thing. They write this thing.
Sir, where we can find 001 by R
Okay, 001. See,
or 101 or
yeah,
001.
yeah. How would you write this? Okay, see here. Now let me write the equations. These equations clearly. The first equation, let's say x1 dot. Okay, x1 dot is equal to x2. See here x2. x2 x2 dot x2 dot means x3 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 dot x3 dot means this equation minus 24 x1 minus 26 x2 minus 9x3 plus r. Now see, first equation have only x2, so I'll write 1 only because the coefficient of the x2 is 1. For the second equation, x3 only, so coefficient would be 1. For the third equation, the coefficient of the x1 is minus 24, coefficient of the x2 is minus 26, coefficient of the x3 is minus 9. Okay, now write like this. But what happened to the r? R is another variable. Here see, first two equation, there are no r. Any r is there? No. Because no r, that means those will be 0. The coefficient of the r would be 0. But at the very last one, the coefficient value is 1. Okay, that is the thing. That is the main thing, what you have to take consideration. Okay,
Yes, sir, understood.
you understood?
Yes, sir.
Yes, sir.
Because see, here means 0r. Here also 0, it is 0 dot r coefficient. Similarly, 0 dot x1 plus 2 plus 0 dot x3. Something like that. 0 dot x1 plus 0 dot x2 plus x3 plus, okay, something like that. That is why they do this. Now, if you look at the final one, so final one, say they have found this one. This is the input and this is the output. So CS by x1. So for the final one, since it is output, so it would be CS by x1s is equal to s square plus 7s plus 2. Okay, so take the inverse Laplace transform and multiply it. So CT would be equal to s square plus 7s plus 2 into x1. Okay, let me erase this t. CS. Okay, now if I take the inverse Laplace transform for this one, and then it would be CT s square. That means x1 double dot 7 x1 dot plus 2x1. Okay, 2x1. So what would be the equation here? So we can write the equation here. Output equation is the C. Output equation is the C. So instead of C, you can write y. Y is equal to 2x1. That means 2. Okay. Now see, x1 means what? x1, but x1 dot means x2, x1 double dot means x3. So we can write 2 7 1. Okay, 2 7 1, and we can write like this: 3 x1 x2 x3, because, or you can write like this: 2x1 plus 7x2 plus x3. Okay, that is your output. So I think they did this. See, something like that: 271 x1 x2 x3. See this. So you do not need to write these theoretical things. Okay, those theoretical things. They explain it. Now you understood? Now check the math, then you will understand. Okay. Now check by yourself.
Okay, sir.
And a state space to transfer function is difficult. Okay, just matrix from just you have to take the matrix, then put the matrix on the formula, then you will get it. Okay, same thing. That is not very difficult. Just you remember the output. Okay, this output.
Yes, sir.
Remember this formula and make the matrix like this. Okay, then you will get this. That up to that.
Sir, 3.6 is adjacent.
Yeah, adjacent is another technique. You have to check on the online. Let me find a book. Just a minute. Just a minute. I will share another thing for adjacent. Okay, see. Have you seen this?
Yes, sir.
That I was looking for that. They have changed the location. Okay, matrix definitions and notations. See, matrix, you know the matrix, right? That is the matrix, and you know the vector. If a matrix has just one row, it is called a row vector. Okay, if a matrix just has one column, it is called a column vector. Okay, now partition matrix. What are the partition matrix? See, a matrix can be partitioned into component matrix or vectors. For example, like this. That a, okay, so it could be the partition matrix where a1 1 or a2 1 a2. Now that is the null matrix. That is the diagonal matrix. See, just a diagonal like this. An identity matrix, that means one, diagonally one. Symmetric matrix, a square matrix for which aij is equal to aji is called a symmetric matrix. See, an example of a symmetric matrix is this, is the symmetric matrix 387 387 and 2492724. Okay, and matrix transpose. What is the matrix transpose? That means the column will become the row. Transpose matrix is the transpose matrix, column will become the row. Okay, that is the transpose matrix. Now symmetric matrix, you understand this is A11, that is A12, that is A13, that is A21, A22, A23, and that is A31, A32, A33, like this. Now see, transpose matrix means just it changes. Now, how to determine of a square matrix? A determinant of a 2 by 2 matrix, A11, A12, A21, A22. Okay. Now we can write like this: determinant of A11, A12, A21 is equal to just cross multiplication it and minus. Okay, that is how you determine you find the determinant of a square matrix. Okay. Now, if you have something like that, let's say the minor M1j element of Aij of order of determinant A is the determinant formed by removing the ith row and the jth column from the determinant A. Now consider this one. Look at this very carefully. Consider this one. So if I consider this and if I want to M32, that is M11, M12, M13. That means M32 means uh, third column and second row. Okay, M32. See, M32 means third column, third row, removing the third row and the second column, third row and second column. M32 means this one. Third row 514 and the second column. Remove the second column, which remains 3762. 3762. Now 3 into 2, 6. 6 into 7, 47. The cross multiplication it. Okay. So minor M32 is the determinant formed by removing the third row and the second column from determinant A. Thus, that is minus 36. Okay. So how to do this? See this 6 minus 42. That means minus 36. Okay. So how to write the determinant? Minor determinant M32. You can calculate like this. Now, cofactor of an element. Cofactor. What is the cofactor? Cofactor Cij of element Aij of determinant A is defined by this one. For example, given the determinant of equation G14, let's say that is the determinant matrix. Now, what would be the cofactor of this? Given the determinant of equation G14, C21. If I want to C21, let's say 2 means first one, I is equal to 2 and J is the 1. 2, 1. So M21. So M21 multiplied, so it is the minus 25. Okay. Now, evaluating the determinant of a square matrix. So determinant, it is the formula where M is the number of rows of A, M is the number of row, J is the jth column, selected to expand by minors, and CKJ is the cofactor of AKJ. For example, if let's talk about it. A, now determinant of A. If I want to find the determinant of A, so what is the formula? Summation of, this is the summation K1 to M, AKJ, CKJ. Okay. AKJ, CKJ. So just follow this formula. So what is this? Let's say determinant of A. So at first 2 minus 5, 6, 8, 5. Then minus 7, 1385. Then 4, 13 minus 5, 6, minus 195. See, minus on the third column, just minus on the third column. We're completing the minus of the third column. And if we do this on the second row, then it will change. Okay. That is the policy of finding the determinant. And adjoint matrix. This is the adjoint matrix. Adjoint of a square matrix written ADGA is a matrix form from the transpose of the matrix A after all elements have been replaced by their cofactors. So they have to replace the values by their cofactors. See, that is the adjoint matrix. Okay. At first, make the transpose, replace the transpose by their cofactors. Okay. So you have to look at this adjoint matrix and the determinant of a square matrix, determinant of the matrix. Okay, you have to look at this. And some matrix operations are there. I think you know how to find the matrix. Okay, so I am giving this one to you. Okay, so that you can check by yourself. Okay, see, it is the Cramer's rule. Cramer's rule, which we have been used so far very often. That is the Cramer's rule. So just guys, look at this matrix. Okay, then check this one. Now then check this example. So at first see this one, adjoint of this one. So we have to find out the adjoint of this one. Okay, then determinant of this one. Then you will get this kind of output. So you do this by yourself. Okay, I am giving you the matrix definitions, matrix example. Then you check by yourself and find out is it correct or not. Okay, because since it is not the whiteboard, so it is very difficult for me to complete all the math, whole math. Okay, so I have shown you the output. Just a minute. See, are you seeing anything?
Yes, sir.
See, so here you check the determinant, how to find the determinant. Okay, so now if I look at this one, so determinant, if you want to find the determinant of this one, then apply the formula, then you will find this equation s cube plus 3s square plus 2s plus 1. Then do this one. Okay, so if you want this kind of determinant, then you have to check cofactor. You have to apply this kind of formula. Okay, so that is the way to find this determinant using the cofactor also. So apply this and check. Okay, so if you apply any one, then result will be same. Okay, so you can apply this one, just take this following this one. Let's say this one, just take this one into consideration and make the determinant 0s12. Okay, then you will find this one, and also the adjacent for adjoint matrix. For the adjoint matrix, take the transpose and here apply the formulas. Okay. Then you will find the output, this kind of matrix. So adjoint and determinant. So find the adjoint and the determinant, then divide it. Not very difficult, just you have to check. Okay. You have to check it by yourself. So that
Okay,
is
sir.
up to chapter 3. Anything else?
No, sir.
Okay. So the final thing, the final words, that your exam will have two part. First part has 10 marks, which is a viva, and another 10 marks would be the question answer, like your exam. Okay, I'll give you some questions and you solve it, take the screenshot and make a PDF, then submit it. Okay. So that is the thing, I think. Clear?
Yes, sir. Yes.
And so I think I should can I stop it, or anything else you want to know?
No, sir. You can stop it. No problem, sir.
Okay. So I can stop this one.